We have what we call the David Saurman Provocative Lecture Series, and we bring speakers, 3 speakers a semester here. We've tried to make it speakers who have things to say that we're maybe not used to hearing all the time, and so we're very fortunate today to have Professor Barbara Oakley come and speak with us. And she was with us last night, so I don't think Lydia's here. I could say Lydia's managed to work her harder than we work most of our speakers. I think she's gotten 3 talks in now in less than 24 hours, so I have to congratulate her for that. That just gives you a sense of what Lydia does for our department. Anyway, we usually have a little meeting after this, and we go down to Flames, but today, after this, we'll have coffee and cookies outside. So I hope you'll stay around. You have an opportunity to talk with Barbara a little bit, and also some of the faculty from different departments here and different schools as well. I welcome you all. Barbara is, I've gotten a chance to talk with her a little bit, and she's led a very interesting life. I should say a few things about her. She's the Associate Professor of Engineering at the Department of Industrial and Systems Engineering at Oakland University in Michigan. Her work is focused on the complex relationship between neurocircuitry. I did that last night, I think, as well, didn't I? My neurocircuitry is not quite working well. And social behavior. She is the recipient of the Oakland University Teaching Excellence Award in 2013. As I said last night, I think that is a great honor. To be recognized for your ability to teach, I think, is something that we could all aspire to. She's also received the NSF Antarctic Service Medal, which tells you something, because she's been in at least several cold places. I think she has an affinity for cold places, maybe. Following her work as a communication expert at the South Pole Station. Prior to her academic career, Barbara also rose from private to captain in the U.S. Army, not an easy thing to do, during which time she was recognized with a distinguished military scholar, as a distinguished military scholar. She also worked as a Russian translator aboard Soviet trawlers in the Bering Sea. I'm sure that's a very easy job. And she was elected a fellow of the American Institute of Medical and Biological Engineering. Not bad. Kind of a varied career, right? Professor Oakley received a Bachelor of Arts in Slavic Languages at UW, University of Washington, while in the Army, and returned to school for a BS in Electrical Engineering, not 2 fields that you would necessarily put together. She then attended Oakland University, where she completed an MS in Electrical and Computer Engineering and a PhD in Systems Engineering. She spoke last night about pathological altruism, and of course, following right on that, this will be how to excel at math and science. The 2 seem to go together quite well, right? And we'll see how those 2 met. She was hired upon graduation and continues to teach at Oakland. So let's give her a warm welcome. Thank you for coming.
Thanks so much. Thank you so much. It's such a great pleasure to be here today. I especially appreciate Jack Esteel's introduction, and then Lydia Ortega has been so kind in inviting me here. She's an extraordinary department chair, and I think I've been very deeply impressed with what's going on in the school, or in the Department of Economics. So what I'd like to remind you of is learning is extraordinarily important. It's so important that we often spend among the first 12 to 16 years of our lives in formal education. Yet we rarely learn how to learn. So that's what I'm going to be talking to you about here today. Now, as I mentioned last night, I grew up moving all over the place. So by the time I hit 10th grade, I'd lived in 10 different places. Math is extraordinarily sequential. It's easy to fall off that wagon someplace along the way. I fell off in about 3rd grade. So I just didn't have an interest, and I didn't have an interest in science either. So what this meant was I essentially flunked my way through elementary, middle, and high school math and science. So it's kind of funny looking back on all that now, because I'm a professor of engineering. So one day, one of my students asked me, he said, how'd you do it? And I thought to myself, how did I do it? I was just a little kid that loved language and culture, and that's all I wanted to study when I grew up. But I didn't have the money to go to college and study those kinds of things. So what I did instead was I enlisted in the Army, because that way I could at least get paid to study a language. And I ended up studying Russian, and I finally ended up working on Russian trawlers, Soviet trawlers up in the Bering Sea as a Russian translator. And it was really exciting. It was fun. I loved taking in new perspectives. In fact, I ended up also working down at the South Pole Station in Antarctica. That's where I met my husband. So I always say I had to go to the end of the earth to meet that man. But I began to realize that if I really wanted to take in a new perspective, to learn something new, why didn't I try looking inside my brain and seeing if I could make some changes there? When I was working in the Army, I knew all these West Point engineers, and they seemed to have these powerful techniques for thinking about and analyzing problems. I'd pick up the books in their office, calculus and physics, and I'd open them up and it looked like hieroglyphics. But I thought, what if I could understand some of these ideas? What if I could add these new ideas to the things that I already knew and loved, involving language and culture? So at age 26, when I got out of the Army, I decided to try to retrain my brain. It was not easy. But if I had known then what I know now, it could have been much, much easier. Several years ago, when I started trying to answer that student's question, how did I change my brain? I began writing to hundreds of top professors around the country, people who taught in subjects like mathematics, engineering, chemistry, even English. And I began asking them, how did they themselves learn their subjects? How did they teach so students could learn? These were people who were world-class teachers. And what I found was that these people taught and learned themselves in the same way that I had taught and I had learned myself, right? And the same way that I taught my students. So it was almost like this shared fraternal handshake. We all knew what we did, but we often didn't know why we did it. So I began looking into neuroscience and cognitive psychology and corresponding with some of the leaders in the field. And today, what I'm going to present to you is what I found. So when you're learning something or when you're thinking about anything, the brain is filled with complex activities. I'm going to show you here, just give you a little sense, how does your brain respond when it hears a single word? Watch all the complex activity that takes place. Isn't that amazing? One single word, and there's all these activities throughout your brain. Now imagine what's taking place when you're trying to solve a problem. It's incredibly complex. But as you learn, in math and science and engineering and all these different kinds of disciplines, just as in the humanities and social sciences, metaphor and analogy plays an enormously important role. So we're going to use an analogy today to help us understand and simplify some of the ideas about how your brain works when you're learning. So the first thing we're going to do is we're going to talk a little bit about, as you can see here, I think you can see here. Anyway, You can see, here's your brain, right? And you've got your cute little ears right here, and you've got eyes looking out up above, right? And we're going to use an analogy of a pinball machine. So a pinball, if you remember how pinball works, what it does is you pull back on the plunger, and a ball goes boinking out, bouncing around on the rubber bumpers, and that's how you accrue points. And we're also going to talk about zombies, because I like zombies, right? So at any rate, when you're learning, there's actually two fundamental modes of learning: focused mode and diffuse mode. And these are two fundamental modes that your mind automatically works in. And it is either in one mode or it's in the other mode. It's not in both modes at the same time. So what are these modes? First, focused mode is when you turn your focus on something, right? And so it's almost like a flashlight. You turn your flashlight on and it's there. Boom, right? And focus mode often relates to something that you're at least somewhat familiar with. So you can kind of think of it like that orange pattern right there. There's that's a pattern that you're, in essence, kind of familiar with, right? It's already, there's neural framework there that you're, that you've done somewhat before. And it might be something like you know how to multiply numbers together, or to do an integral or something of that nature, whatever you're familiar with. So when you think a thought, it takes off and it starts ricocheting around, and then it ends up kind of going along right along the pathways that you're already familiar with. But what if the idea that you're trying to grapple with, for example, a new problem, involves something that you haven't really learned about before, something brand new? You can see that symbolized here by this black pattern on the bottom of the pinball machine. How do you even get to this area of the brain, right? There's all these pinball rubber bumpers in between, so it's hard to get to, metaphorically speaking. So how the brain actually gets to these new ideas is often by using the diffuse mode, a more relaxed state of thinking. In this mode, what happens is you think a thought and you can think much more broadly. It's easier to kind of get to new places in your brain. So you may not be able to do the focus mode thinking that you can in this framework, right? But you can at least get to a new place, for example, here, and then you can begin thinking in more careful focus mode fashion. So how does this relate to us in our everyday lives? If you look at that guy right there, he was Salvador Dali, one of the most famous surrealist painters of the 20th century. He was the very definition of a wild and crazy guy. I mean, he was Lady Gaga long before Lady Gaga. You can see him there. He's with his pet ocelot, Babu. And what Dali used to do was he'd sit with a key in his hand, and he'd relax in a chair, and he'd be kind of thinking gently about maybe some problem he was working on, a piece of art. And he'd relax, and then just as he'd be falling asleep, the key would fall from his hand, clatter on the floor, and that would wake him up. He'd come back, and he'd have some new ideas from this diffuse, relaxed mode of thinking. Come back, take it back into the focus mode, and then he could work effectively with these new ideas. So this back and forth between focused and diffuse was very effective for him. So you might be thinking, well, yeah, that's great for an artist, right? But we're talking about, isn't my session here about learning in math and science? So what does that have to do with that kind of thing? Well, if you look at this guy right here, he was Thomas Edison, one of the most brilliant inventors in history. Now, according to legend, what Edison used to do, he used to sit with ball bearings in his hand, relax in a chair, and he had a tin plate down beside him, And he would allow, just relax. And just as he would fall asleep, again, the ball bearings would slip from his hands, and the clatter would wake him up, and off he'd go with his ideas, back into the focused mode. And then he was able to take and think creatively about the inventions that he was working on. But, again, you may say, well, yeah, that's great for these really creative types, but I'm just an ordinary person, so what does this have to do with me? But think about it this way. Every time you sit down to solve a problem, in math or science, or work on something in English, or create, it's always you're creating something new. Thousands, tens of thousands, millions of people may have thought the same thought before. It doesn't matter. For you, it's a new creation. And you're using some of the same approaches that these people have used to be so successful in their lives. It takes time to learn effectively. Basically focusing intently in one session to try and figure out a problem or work on something and get a solution is often the worst approach possible. You box yourself into a solution. You must also use this other mode of thinking in order to be able to grapple with and assimilate new ideas. It's almost like a weightlifter. If you were a weightlifter, would you wait until midnight the night before a big meet and then practice working out, right, to build your muscles? You would never use that kind of approach, right? It takes time to build muscular structure. In the same way, it takes time to build new neural scaffolds when you're learning something new. So you may say, but wait, I love to procrastinate. I'm a procrastinator. Is anybody here a procrastinator? Sometimes I would have meetings with my class, and I would start them out, I would say, hello, I'm Barbara Oakley, and I am a procrastinator, right? Because we all procrastinate. Whenever you're working on something, you're not working on a lot of other things. But some people have a lot more problems with procrastination than others. And so I'm going to give you some ideas about how you can deal effectively with procrastination, because that actually is a key problem that blocks success in learning difficult subjects. Now, procrastination is simply a habit. So what happens, as researchers have found, let's say, pick whatever your most unfriendly subject is. Let's I don't know, we'll pick on accounting, I guess, but it can be anything. It can be French, it can be, math or whatever. So you look at that accounting book and you say, oh, my goodness, I really don't want to do this. And what's happening is there's an area of your brain that experiences pain. It's the same area that if I whacked myself now, right, on the hand, I would experience pain, but that experience would be something I would perceive in my brain. So when you open that book that you don't want to open, you actually feel the metabolism speeds up in that one area of the brain where you experience pain. So what do when you feel pain? You don't like it, right? So you want to avoid it. And so it's simple with this kind of matter. All you have to do is turn your attention to something else. And if you do that, guess what? You feel better temporarily. In that sense, procrastination is truly like a little bit of an addiction. So you feel a little unpleasant, so you do something to make things better, and it feels better temporarily, but in the long run, it can really, really affect your ability to be successful. So what can you do to be more successful, to help develop your ability to focus more effectively and to avoid procrastination? There's a simple little technique called the Pomodoro Technique, and it was invented by an Italian, Francesco Cirillo, in the 80s. And what this technique involves is something incredibly simple. All you do is you take a timer and you set it for 25 minutes. And then you turn off anything that can distract you during those 25 minutes. So, no cell phones, no instant messages, everything goes off, and then you sit and focus for 25 minutes. So 25 minutes, pretty much anybody can do 25 minutes of focusing. And then afterwards, you do something to relax. Just a little bit, a few minutes of web surfing, chatting with friends, have a cup of coffee, whatever. So what you're doing is you are doing a practiced way of focusing and then relaxing. So you're helping to build both modes as you're working with this technique. Now it's important when you're using this technique, do not sit and think, I'm going to use these 25 minutes and I'm going to finish this task. Don't think that way. You must focus only on the process of focusing, right? And being as effective as you reasonably can be. Don't worry about the product of what you want to be working on. Now, related to this idea is this. It's important for your life and your life of learning to always try to set a finish time. So during the day, what you want to do is you want to work intently and with focus, and then you know that you have a quitting time. Depending on what your responsibilities are, you may be able to quit at 5. You may not be able to quit until 9 o'clock at night. But you need to set a good quitting time that you know you'll stop, because that allows you to focus and work effectively and then be able to relax afterwards. And that can help you really succeed in the long term. Another little technique that goes with this is just the idea of eat your frogs first. Often people find that the first thing in the morning, if they'll do a Pomodoro on the one thing that they don't like the most, right? If you don't like studying a language, get that out of the way. Just do a Pomodoro on it. And by doing this, by eating your frogs first, doing the hardest thing first, you find yourself actually being more successful in the long term. And another little thing I just want to give you insight about. You are often told, follow your passion in your learning. But there's a thing about that. Passion often involves something that you're really good at. But it takes time to get really good at some things that are very difficult. So be open in your passions. Don't lock yourself out of interesting passions simply because it takes much more time to develop some of them. Now, what I'm going to do now is I'm going to give you a little sense of what research is showing are the most powerful techniques for learning. So we're finding now that you've probably heard a lot of people don't like testing, right? Tests, you have to correct tests and so forth. But actually, tests are amongst the most powerful and effective ways to learn. So if you're a student, one of the ways that you can learn most effectively is by giving yourself little mini tests all the time. If you're a professor, the more often that you can test your students, the better. It will allow that testing experience somehow speeds up your adrenaline, and you're thinking more intently, and you actually embed the ideas more deeply in your mind. So flashcards are your friends, right? They help you to analyze, to embed these ideas in your mind. Even in math and science, they can be very effective. And so what I'd like you to do now is I would like you to stop, turn to someone who you do not know, introduce yourself, and I'd like you to just kind of see what you think is the most interesting aspect of this lecture so far. So 2 minutes, Mark, get set, go. So is everybody ready again? That's the the one thing about the one thing about active learning is that sometimes people get so excited about what they're learning about that the only problem is it's hard to get people to stop. So, I mean, if that's your main problem when you're, learning something, that's a really good problem to have. So let's talk about some other things that might be helpful in your own learning. I want to give you a little bit of an appreciation for the idea of illusions of competence in learning. Researchers are finding that this is an extraordinarily important idea. Students learn, they think they're learning, but they're actually not learning. What they're doing is putting time in, but often the time that's being put in is being put in a very ineffective way. So students, in essence, are fooling themselves, and they do this all the time. So if you test yourself early and often, or if you're a professor and you give tests early and often, this can be very effective in monitoring whether you're truly learning something or whether you actually simply have an illusion about whether you've learned the material. Now, I think one thing that's very important is you want, when you're learning, or if you're helping people to learn, you want to offer pointed encouragement without providing a crutch. And in this regard, there's a very important paper that was published by Joan McCord in 1978. What McCord did, she went back in the 1930s and early 40s. There was a group of 500 Boston schoolboys aged about 7 to 13. And they took these 500 schoolboys and they divided them into two groups. One was the control group. They did nothing to this group. The other group was given a great deal of tutoring, summer camps, benefits of all sorts, psychiatric counseling, medical help. They gave them the best that they could to really help people. And what they found, what Joan McCord did, was she followed up on these 500 students 30 years after this. These students had 5 years of care like this, right, or no care. And what she found was that the group that had gotten all this care thought that it was very helpful for them. But when you actually analyze the data, here's what came out of it. These students ended up with more criminal behavior. They had more problems. They ended up in lower class jobs. They died earlier. They had more high stress diseases. They had problems of all sorts. How could that be? All this helping behavior, and it actually seemed to do a disservice for students. So part of what I think it is learning has to come from within. And if you begin to rely overmuch on others, that can actually do a disservice for you in your own life. So one thing that happens is, for example, let's say a tutoring center is incredibly important. It's a valuable, valuable resource. But sometimes people misuse them. What happens is, if they're like me, and I am the classic example of how not to learn in math and science, right? What I used to do I remember my poor high school chemistry teacher, Mr. Fry. I'd come up to him and I'd be like, "Come on, Mr. Fry, I dare you. See if you can get it in my brain," right? I was no help whatsoever. And you have to actually do the work yourself before you can be receptive to the help that can be provided by both your teachers and by tutoring and assistance centers. Sometimes I think what happens is people will say, I'm going to go to the tutoring center and I'm going to get help. And that means they can procrastinate on working on anything, right? And so you have to be very wary. When help is available, it must be used wisely something that's used as an adjunct in answering questions that you've carefully developed by analyzing and working on the material yourself. No one can put that in your mind if you're not prepared to do some of the work yourself. Now, so let's talk a little bit about test anxiety. Now, let's pretend that a bear came right out of this screen right now into this room and started kind of rampaging towards you. How would you feel? You'd probably like, yeah, they'd be like, oh my God, there's a bear, right? So oftentimes what happens with test anxiety, students will say, I knew the material, right? But then I sat there and, I started, and I panicked, right? But remember, it's almost like, remember those illusions of competence. You can think you know the material, but it actually, push comes to shove when you sit down to look at it. And if you haven't prepared carefully, of course, you feel panic. That's when it really becomes apparent. There's a bear there, right? And so, of course, you get that reaction if you haven't prepared in a way that truly grapples with and understands the material. So I was surprised myself. I have taught for a number of years, and I began to observe over the years that I'm a very strong proponent of active learning in the classroom, and so I have my students evaluate one another on teams. And I found very often that students who would come to me and say, I really know the material, but I just suffer from test anxiety. When I would look at their peer ratings, what the peer ratings would say are things like unsatisfactory. They failed to show up or complete assignments, unprepared, right? Superficial, practically no participation. So oftentimes these students would say, I really knew the material, I just, suffer from test anxiety. No, it was an illusion of competence, which is so very common in learning. So a few additional key points from research. Recall is extraordinarily important in learning. So what do I mean by this? They did a study appeared in Science, and what they did was they asked students to learn some material about science by reading the material. And they also asked them to do concept mapping and rereading. And then they asked them to try one additional technique. And this was, they'd read the material, and then they'd simply look away from the page and see if they could recall it. They compared all these techniques, and they found that the most powerful technique by far is not rereading, not highlighting, not concept mapping, but simply looking away from the page and recalling the material. So recall seems to begin building those neural hooks that help deepen your understanding of the material. And one thing I want to kind of remind you about is, one thing you can do with recall is you can recall by looking away from the page. But more than that, you can also recall in different locations. So you can go elsewhere, not just sitting in, where you can usually study. It's found that when you study in one location, you often are prompted in remembering what you learned by what's going on around you in that location. So like you remember sort of the feel of the room. So if you also recall in different locations, what you're doing is you're prompting yourself to not be location specific in your memory, right? In your ability to think about these ideas. So you want to, as I mentioned, avoid highlighting. What highlighting does is it gives you the illusion that you've learned something, right? You're moving your hand across the page. So you think you're learning something and you're actually not. If you highlight, keep it to a bare minimum and try to make sure you recalled it, the key idea, before you make that mark on the page. Avoid passively rereading. I must have spent weeks, hours, months rereading and rereading material, and now I know that's actually often a waste. You want to recall, and just simply rereading just makes you feel like you know it, but you actually aren't really learning. So a serious problem. You've probably been told by your professors, understanding is the key, right? If you understand, that trumps everything else. Well, guess what? It doesn't. You can understand something, and if you don't practice it and repeat it, it will slip away. Your little metabolic vampires will draw away the buds from those neurons, and it will be as if you didn't learn it in the first place. That's why you can often be at a lecture, you understand what they say, and you forget to review it, or you don't have time, and it slips away. And then when you look at it, you can't really understand something that you actually understood before. So another really important thing is sleep. Recent research is incredibly exciting, and what it's done is it showed that when you sleep, what happens is your neuron, or some of your cells will shrink, and that allows channels to open up, right? And so it washes away the toxins that develop through the day, and you're able to function much more effectively. So if you go the night before without sleeping, you've essentially left a bunch of poisons in your brain, and you can't function as effectively when you're doing the test. So all of your previous work can mean nothing. So again, without sleep, it's as if those focus mode connections just don't work properly. So what I'd like is, again, let's do one more little active learning exercise. And what I'd like you to do is, what do you think is the most powerful technique you've learned about here today? And if you would, talk with someone who is near you and see what they think, and kind of compare notes about what you think was the most powerful technique that we've covered. And on your mark, set, go. 2 minutes. Okay, so last little bit here, and now my voice is back, apparently. So what I'd like to talk to you, just the last little note, now that I have your attention, right? When you turn on your focused attention, what that really does is that allows you to be able to focus. It's your prefrontal cortex, and what's happening is your prefrontal cortex, you can kind of think of it as it has slots of working memory. It used to be thought that we have 7 slots in working memory, and I always wondered about that because I couldn't remember 7 things at once, right? But now latest research is beginning to show it's more like 4 slots in working memory. And what happens is, you can think of it as when you have your focus mode, it's almost like you're turning on and making connections with this octopus that appears, and it connects through the slots of the working memory to make connections in your brain, right? So you can connect up to 4 different things. Some people are better, some are worse. But what happens is, let's say you're sitting there and you're trying to focus and learn something, but what you're actually doing is you may be kind of keeping an eye out on some other kind of thing that's going to show up, right? So in other words, you're maybe listening to a little television in the background, or you're listening for an instant message to arise. What that's the equivalent of is sort of, it's like taking one tendril of your working memory away. In some sense, it's almost making you a little more stupid, right? You can't make as good or deep a connections when you're listening with more superficial sorts of attention. Now, let's contrast that with diffuse mode thinking. Diffuse mode is more like you're making these random connections, right? And that's why you can be more creative in that mode, but it's hard to focus and keep control of what that thinking actually is. So working memory and chunking it's like this. You've got your 4 slots of working memory, and let's say you have this raw information that's kind of like a puzzle that you're trying to piece together. So as you're trying to piece it together, what happens is your working memory is really busy. It's making all these connections back and forth, right? But once you have it pieced together, you notice that guy right there? That's my husband. So once you've got that information chunked and in some sense understood, what it's the equivalent of is like making one smooth neural strand, right? And what that does is it frees up the other spots, the other slots in your working memory so that you can use them to make new connections. So that's part of why it's important to practice and repeat and become very familiar with ideas, because these help build chunks that free up your working memory so that you can think more easily about things. Now, what is memorization without understanding? You can kind of think of that as it's the equivalent of this cut-out circle here where you can't make connections as you can normally with a puzzle piece, right? It's just this block that's sitting there all by itself, and you can't really make good connections with that. Practice is extraordinarily important. Practice and repetition. Practice and repetition is important in learning language, in learning music, in learning dance, in learning virtually anything. And it's also important in learning in math and science. So what happens is the more you practice, the more you repeat, in some sense, it's like you're making that pattern darker and darker, and it becomes a good chunk that you can easily draw on. So if you don't practice and you don't repeat, what happens, again, you can kind of think of it like these little metabolic vampires that suck away some of the buds on your neurons, and the patterns disappear as if you'd never known them. So one way to easily create a chunk that is something that you can remember is to explain so a 10-year-old can understand. And that is something that Nobel Prize winner Richard Feynman strongly emphasized. He would challenge mathematicians in some of the most advanced subjects to come up with simple metaphors and analogies for what they were studying and working on, and they could always do it. So in that sense, it's similar for even complicated topics. If you can explain it simply using a metaphor, it allows you to learn it more deeply and also to carry it more easily, right, in your mind. The simple one for us in engineering is often just that idea that electrical current flows like water. At some level, sure, any analogy and any metaphor is going to break down. But hey, it helps get you started with an essential neural scaffold that you can build on. Just to touch on this idea, when you're learning something, try not to beat it to death, whatever you're learning, especially in math and science. Don't do 20 problems of the same type. This is the equivalent of saying, I just learned how to use a hammer. So I'm going to use a hammer to drive in this screw, to drive in this nail, to turn. I mean, it's like you think you can bash everything with that hammer. You want to interleave different types of problems. That's very, very important for learning of all types. So make sure that when you're learning something, like if you're in section 9.2, do 2 problems from 9.2, then skip back to 7.1, something completely different or something related, and then go back to 9.2, and then maybe go to 6.4. What this does is it gives you practice in learning which tool to pick up, right, as you're learning something. What you're doing as you're learning is when you practice and learn some technique, some idea, some problem very well, it deepens these patterns. And then what you can do with your diffuse thinking is make connections between these patterns. In some sense, you want to build a solid library of chunks, and then you can use that to help you to be more effective in homework and test problems. I want you to be aware that there are paradoxes in learning. And what teachers often do, professors, is they think they'll seize one handle of the paradox and say that's the important thing. And they forget about the other handle, right? So what I'm talking about here is things like this. We often tell people that focused learning is a really important thing. That's how you learn. But actually, sometimes you get yourself in a box by focusing. You have to not focus on the very thing that you want to figure out in order to be able to figure it out. So focusing is indeed important, but sometimes you have to stop it and do diffuse, relaxed thinking in order to be able to solve problems. We also know that, for example, understanding is really important, but it is not the only thing. Besides understanding, recall, memory, repetition, these are also really important. So it's important to understand both of these aspects. They power our learning. Helping is important, but too much helping actually can hurt, can backfire, and lead to consequences that are exactly the opposite of what we're trying to aim for. So in summing everything up, here's kind of everything in a nutshell, right? These are the basic ideas that we've covered today in our talk. And I think it's important to realize in the end that learning math and science is really very much like learning music. You want to practice, you want to gain power, you want to be able to perform in front of an audience even. And when you do that, you realize the power that's within yourself. So with that, I want to thank you ever so much for coming here today, and I hope this helps power your learning. Thank you.
So we have a few minutes, and I'm sure there's going to be a multitude of questions. I don't know if we can get through them. But I do want to say a couple of things. First, Barbara has a new book coming out. It is, let's see if I can do this right now. Thank you. A Mind for Numbers. You can excel at math and science even if you flunked algebra. How am I doing? Was that close?
That's pretty close.
Okay,
yeah.
So I do have a sense of that from struggling through some math myself. And that book will be available at the end of July, we think, now. So that's something to look for. Also, we are taping this, and it will be available on the Department of Economics website probably within a week or so. You can go to the Department of Economics, look under Provocative Lectures, past lectures, and there's a link to a whole series of lectures there, including last night's and today's. Okay? So if we have any questions, if you hold up your hand, I'll kind of keep track of you, and I am happy to give you the microphone. That's all right. Everyone will be able to hear you better this way.
Thanks. I had a question about taking notes in class. In my undergraduate classes, I had a friend who always got like 100 on tests, but he never took notes in class, and he would cram like the week before. I think we kind of covered cramming's not the best thing, but for some reason in class he never took notes, and I just found it like consistent with people who did well on tests. They didn't take notes; they just sat there and took it all in. Do you, if you can comment on that, that'd be great.
I've observed that myself. Such students aren't real common. I believe that what happens with students of this nature is when they're watching, they have a pretty good memory, and they're able to chunk the ideas and capture them very quickly. So it all depends on your underlying, biophysiological makeup. Some people are able to really power through and keep a good memory of what's going on. Others have to take notes in order to keep those kinds of ideas in mind. Now, one thing that often happens is people who are like this, occasionally they can go all the way up through advanced, into graduate studies and so forth, and they do just fine. For most people, what happens is they do great in high school. And then they get into engineering, or they get into, they start getting into college, and they find that those techniques don't work anymore, that it just gets too much for them, and then they end up moving into other disciplines because they haven't learned these learning techniques that more normal people. What you'll find is it's actually the people who are highly successful in life are often not the ones who can grasp all this kind of things and retain it, and they're perfect. They're the ones who are really persistent, who really keep track, and they use whatever mechanisms they have to be able to be successful with the material. And so I think that's very important. And sometimes it can be helpful to be a slower learner because you also learn these techniques for learning and you learn how to be persistent. I also do notice that people who are really fast, they often also jump to conclusions. And so they'll go off track more easily, right? And so people who think a little more slowly, it's almost like the difference between somebody that speeds past on a Maserati. They've got this great brain, right? But they miss all these little side roads and they don't get the smells, they don't get and these kinds of things, all those little interesting asides are often very important aspects of whatever you're trying to grapple with. So sometimes the slower learner actually gets it more deeply. So these are all just factors to consider. Everyone's different, but you can use your own seeming problems to your benefit if you're smart about it and very persistent. More questions?
So it's 3. Have you learned any other languages, and have they been helpful to you in your field, engineering? Because I know you learn Russian, right?
Right.
So, because I've been thinking of learning another language too, but is it beneficial if you work with abroad? You know, I don't know.
If you work with
if you work abroad, if you live here, but then you can be sent over to, say, France, Germany, and be working with other people, or in your case, Russia. And was it helpful to you if I don't know if you've ever, worked with anyone else in your field that only spoke Russian, but you understood it, and, has it been helpful?
Learning another language is helpful in so many different ways. What I think it's almost hard to begin with all the benefits. For me, learning another language before I ever started learning math and science was actually extraordinarily helpful, because I learned that a lot of these ideas with practicing, with trying things out loud, with frequent self-testing, that those are very effective in learning a language. And they're actually very similarly effective when you're learning math and science. So I think one thing that people lose sight of, just because of the natural separate silos of different disciplines, for example, in mathematics versus learning French or something, they lose sight of the fact that there's an underlying commonality in how we learn these kinds of different disciplines. And if you learn one, it actually will really help you in your ability to learn another. Another thing I like about learning language is what it does is you have to do careful focused mode if learning, right? Memorizing words and so forth if you're learning as an adult at least. But you also have to do this sort of diffuse free-form thinking, right? Because when you actually start talking to somebody, you can't anticipate exactly what's going to be said, and you sort of have to be more free and easy. And that same sort of thing happens when you're learning math and science. You have to start out with some plug and chug kinds of things, but then you start being a little more free form and thinking more creatively about what you're doing. It's very analogous in the approach. But also, of course, learning different languages opens whole new worlds for you, right? Knowing language and also having a technical expertise or some kind of a practical ability, between the two of them, doors open wide. And so all sorts of exciting things can unfold for you. So I think it's a wonderful, wonderful idea. If you're strong in one area, try and get a little in the other area. If you're strong at languages already, try and get a little bit of, the world is evolving. So language and culture are always going to be important. But now technology, math, and science are also important. And so kind of open your world, and I think you'll see wonderful new things coming out of that.
So I have a question about the idea of the diffuse and the focused thinking. It seems like getting into a mode of diffuse thinking takes practice. Like, there's so many things that we have to do every day that keep us focused that it's almost difficult to switch from the focused thinking to the diffuse thinking. So are there techniques to sort of get you more practiced at switching into this diffuse mode?
In my book, I have sort of a list of recommended ways of getting into more diffuse. Diffuse is kind of harder to do. It's not like focus. Focus, you turn it on and zap, you're right there, right? Unless you're tired or something. But focus, you can't do it so easily on command. But many people, for example, we have Neil Sundaresan, who's here visiting. He's the director of research from eBay. And, Neil often finds when taking a shower. And a lot of people find that when they're relaxing, you don't have to do anything in the shower, right? You're just kind of there, or going for a walk, exercising of some sort. These are great ways. And another thing is exercise itself. What they found is with mice, for example, if you have little mice and you put them in an environment where there's not a lot of stuff, their brains actually grow stunted, except for one condition: if they're allowed to get exercise. Exercise allows the neurons in your brains to grow. So the more you can exercise, and also you're using sort of diffuse a lot of times, there's so many stories of great writers, inventors, creators who get their ideas when they're out walking or they're out for a jog or something like that. So that's a great way to do it. But I think that just tells you we so often emphasize the importance of focusing, and then it is really important. But relaxing and doing nothing, being a little mindless, is also really important. So, very good question.
Is there a single life experience that made you the person you are today?
Yes, meeting my husband.
Any other facts, any other? What about past, what other experience that made you the person you are today? Let's say, does the Army make you the person? If it had been for the Army, would you still be the same person you are today? Does the Army help you?
This is such a good question. And I think underlying this question is the idea that being open to new experiences, whatever they are, is probably what made me the person that I am today. And so that played out in a lot of different ways. When my father said, I'm not going to pay for you to go to school to study language, and so I just was like, then I'll just join the Army. And he said, you'll get a great education that way. And so I did and went off. At the time, it's funny, when I do all these things, I was always a nervous wreck. What am I thinking of? I'm joining the Army, or I'm going off and working with the Russians. I still remember, going out with them. And that first evening, it's really noisy on the boats, and they're all like, here, come on, have something to drink, right? And it was the wildest and craziest party. We ended up swinging from, the hawsers over one of the holds and so forth. And I'm like, oh my gosh, what have I gotten myself into? But I think being open to new experiences, when they come along, it helps broaden your perspective even more. I do think that the Army was helpful for me, and Jack and I were talking about this beforehand. One thing that it does is it makes you very aware that you don't want people telling you what to do who you don't think should be telling you what to do, right? They're not as... and I wanted to get into a situation where I was more in control of what my future was. And I think the Army allowed me to see that that was a very important thing that I wanted in my life. But all these different experiences, I think, have played a role in unfolding. And I always get these questions, and I'm like, how do we learn effectively? And then being persistent in following up on these questions and using the skills I learned as an engineer to be able to analyze the underlying science, but then also being able to use the experiences that I had as a linguist and as a writer to communicate these kinds of ideas effectively. So I would say, if I can just say anything, is just be open to new experiences. Try not only, trying exciting external experiences, but try changing your brain as well. Try things that you think you can't do. Be a little persistent at them. Get past those initial hurdles. I still remember sitting there. Here I am, 26, and there's like these 18-year-old high school hotshots, right? And I still remember this one guy. He grabs my calculator, and he cleared it, right? And you know what he was? He was like, what's she doing here? I'm going to make sure she's probably putting all the answers in her calculator, right? And I was like, no, I actually powered through this material and got it. But it was hard at first. I wasn't as good and successful at all. Sometimes I would outright flunk tests. But I continued to power on, and I developed these techniques for learning. And it turns out these are the same techniques that are used by lots and lots of very, very effective professors and learners. So I'm hoping that they'll be as effective for you as they were for me.
Okay, we've run out of time. We actually went over a little bit, so thank you all for coming. And we will be having coffee outside, so if you have a few more questions, feel free to step up and ask. Thank you all for coming.